Ever feel like you're just drowning in project details and then suddenly, bam, there's a huge problem you really wish you'd seen coming ages ago?
Oh, yeah. Finding those critical issues late, I mean, after the code's written, systems running, that can be so painful and expensive.
Totally. It's that classic software development cycle, right? You test it by running it.
And then you find something fundamental is wrong, but like, what if you could dodge a lot of those late game surprises?
What if you could spot key problems before you even hit run?
Exactly. And that's the big idea we're really digging into today.
We've been looking at some foundational material. It's from the Certified Tester Foundation level syllabus.
Specifically, the bit on static testing. Yeah.
So think of this deep dive as, well, understanding how you can find issues just by looking at things, not by running them.
Our mission here is to unpack it all. What is static testing? How's it different from dynamic testing, the execution kind?
Why is it so valuable? And how do you actually do it? Like, what about these review processes?
Yeah, we want to show you how getting good at this stuff can genuinely save time, cut costs.
Improve how teams collaborate, and honestly, uncover insights you just completely miss with dynamic testing alone.
It's all about shifting left-right, being more proactive.
Okay, let's jump in then. Static testing.
Right. The name itself gives a big clue. It's about checking out work products, documents, code, whatever, without actually running the software.
Like inspecting the blueprints for a house before you build it, instead of waiting to see if the roof leaks later.
Exactly. Or, proofreading a script before you start filming.
And that's the fundamental, like the core difference compared to dynamic testing.
Definitely. Dynamic testing needs you to execute the code, click the buttons, interact, see what happens.
But static testing? Nope. You're examining, say, requirements, docs, design models, user stories, the source code itself.
Just by reading it, analyzing it, maybe using special tools that look at the code but don't actually run the program.
It changes how you find defects too, doesn't it?
Totally. Dynamic testing finds defects through failures. You run a test, something weird happens, that's the failure, and that points you back to a bug, a defect in the system.
Okay.
But static testing, you find defects directly.
Oh.
You're reading a requirement or analyzing code, and you spot an anomaly, a potential issue right there. No need for a crash or wrong output.
And that must mean you can find problems in different places.
Huge implications, yeah. The source material we looked at really hammers this home. Static testing is way better, or certainly cheaper, at finding defects where dynamic testing kind of struggles.
Like where, specifically?
Think about code that rarely gets executed. Maybe complex error handling paths, they're hard to trigger reliably with test data.
Right, you might never hit them dynamically.
Or just problems in documents that aren't code at all, like business requirements. How do you run a requirements doc?
You can't. So dynamic testing is limited to what you can execute. Static testing applies to basically anything you can read or analyze.
Precisely. And they focus on different quality aspects, too. Static testing can check, say, code maintainability, or if you're sticking to coding standards.
Or find potential security vulnerabilities just by looking at the code structure.
Yes. Whereas dynamic testing tells you more about performance when it's running, or usability, or if the functions work correctly under load.
So static testing is uniquely good for catching certain common, really costly issues super early on.
You got it. Things like ambiguities in requirements, or inconsistencies, or stuff that's just completely missing.
Finding that before coding even starts must save a fortune in rework.
Absolutely. Or design defects, like a poor database schema, or architectural choices that kill performance later. You won't easily spot those just by clicking around in the final application.
We need to look at the design itself.
Yeah. And specific code bugs, too, like variables used before they're defined, unreachable code blocks.
Stuff a compiler might miss.
Sometimes, yeah. Or things that are logically unreachable even if syntactically fine. Even certain security flaws like buffer overflows are often easier to spot by analyzing the code structure statically.
Okay, I see. And what about testing the tests themselves?
Good point. You can check for gaps in your test basis coverage. Essentially, do your planned tests actually cover everything the requirements demand?
So you can static test your test plan against the requirements doc.
Exactly. Find those blind spots before you waste time running incomplete dynamic tests.
It's amazing how many different work products this applies to.
Yeah.
Requirements, designs, code, obviously, but also test plans, contracts, user manuals.
Models, diagrams, user stories, backlog items, pretty much anything a human can read or a tool can parse if it has structure.
So readability or structure is key.
Right. For manual reviews, if you can read it, you can review it. For automated static analysis tools, yeah, it needs structure code, a formal model, that kind of thing.
The source also mentioned things you wouldn't typically static test.
Yeah, like third-party executables where you don't have the source code. Often legal reasons prevent that anyway, or maybe things that are just really hard to interpret without context.
Okay, so beyond just finding bugs early, what's the big picture, the real value here? Why should teams bother investing time in this?
Well, the number one thing is that early defect detection. It ties right into that core testing principle, test early.
Because it's cheaper to fix problems earlier.
Massively cheaper. Fixing a typo in a requirements doc, almost free. Fixing the consequences of that typo after it's coded, tested, deployed, exponentially more expensive. Static testing lets you make that early catch.
Plus, like we said, it finds issues dynamic testing just can't easily find. Design flaws, unreachable code, those document ambiguities.
And it builds confidence, not just in the running system later, but in the quality of the work products themselves along the way.
And it helps make sure the requirements actually meet what the stakeholders need before you build it.
Critically, yeah. And this is huge static testing, especially reviews, forces communication. It creates a shared understanding.
How so?
Well, getting developers, testers, BAs, maybe even users to all look at the same document early on. It sparked conversations, it clarifies assumptions before they become coded mistakes.
That makes sense. So even if reviews take time up front,
The evidence suggests the overall project cost goes down because you're preventing all that expensive late-stage rework.
and those automated static analysis tools, they must be pretty efficient for certain code checks.
Incredibly efficient for specific defect types, yeah. Frees up developers and testers for more complex tasks.
That point about shared understanding and preventing misunderstandings feels really key. It links to getting stakeholder feedback early and often, right?
Absolutely. The sources really stress this. Getting that feedback early is vital.
Because if you wait until the end to show users what you built,
You might find out you built the wrong thing entirely, which is, the express lane to costly rework, blown deadlines, maybe even project failure.
so involving stakeholders early avoids those massive misunderstandings about what's actually needed.
It keeps everyone aligned, helps the team focus on high-value features, manage risks better.
And a primary way to get this structured early feedback and spot anomalies is through the review process itself.
Exactly. The material we looked at lays out a kind of generic review process, often based on standards like ISO IE 2020-46. It's adaptable, though.
So what does that process typically look like? What are the steps?
It usually starts with planning. This is crucial. You define the scope. What exactly are we reviewing?
Go.
What are the goals? What are the exit criteria? That means how do we know when we're done and the thing is acceptable? You also estimate effort, timelines, that kind of thing.
Makes sense. Then what?
Review initiation. Basically, getting everyone set up, making sure people have the document or code, they understand the process, they know their roles.
Maybe have any checklists or guidelines they need.
Precisely. Then comes the individual review, or individual preparation, sometimes it's called. This is where each reviewer goes off on their own.
Worked independently.
Yeah. They examine the work product, maybe use a specific technique like a checklist or follow some scenarios, and they note down any anomalies, potential issues, questions, recommendations.
Okay, so everyone prepares first.
Then you usually have communication and analysis. Often this happens in a review meeting.
Where everyone discusses what they found.
Right. They talk through the anomalies. Remember, there are potential issues at this stage. The team decides, okay, is this a real defect? Who owns fixing it? What needs to be done?
And they assess the overall quality level.
Yeah, and decide on next steps, any follow-up needed.
Got it. And the final step.
Fixing and reporting. So confirmed defects get logged, tracked, and fixed by the author. The work product only gets formally accepted when those exit criteria defined back in planning are met.
And you report the results.
Yes, report the results. This helps track progress and can feed back into improving the review process itself for next time.
And this whole process involves specific roles, right?
Yeah.
It's not just a free-for-all.
Definitely. You've got the author, the person who created the thing being reviewed. They'll likely be doing the fixing.
Okay.
A moderator or facilitator, really key for keeping meetings effective and on track.
The reviewers, obviously, the people examining the work product.
A scribe who records the anomalies, decisions, action items during the meeting. Often a review leader who orchestrates the whole process. And of course, the manager who needs to support it, provide resources, time.
Right. And reviews aren't all the same, are they? The sources mention different types.
Yeah, very important point. They vary in formality. The right choice depends on lots of things.
Like what?
Like the project lifecycle model you're using, how mature the team's processes are, how critical or complex the thing you're reviewing is.
Legal or regulatory needs, too, I imagine, if you need an audit trail.
Absolutely. All those factors influence which type of review makes the most sense.
So what are the common types, then?
Well, you've got the informal review. Could be just asking a colleague, hey, can you glance at this? No defined process, maybe no written output. The main goal is just quick anomaly detection.
Simple enough.
Then there's a walkthrough. This is often led by the author. They literally walk the team through the document or code.
What's the goal there? Still finding bugs?
Finding anomalies, yes, but it can be broader. Maybe educating the team, brainstorming ideas, building consensus on an approach.
Okay. More collaborative.
Then, stepping up the formality, you have the technical review. This usually involves technical experts as reviewers, and it's led by a trained moderator, not the author.
Yeah, the focus is more specific.
Yeah, focused on achieving consensus on technical problems, evaluating the quality against standards, finding anomalies, definitely more structured.
And the most formal.
That's the inspection. This uses the full formal review process we talked about, with defined roles, checklists, rules, often involved collecting metrics to improve the inspection process itself over time.
And the main goal is just finding as many issues as possible.
Maximum anomaly detection, yes. And a key rule for inspections. The author cannot be the review leader or the scribe. That maintains objectivity.
Wow, okay. So choosing the right type seems crucial for getting the results you want.
It really is. Using an inspection process for a quick internal memo would be overkill. Using an informal review for safety-critical code probably isn't enough.
So it's not just about doing reviews, it's about doing them well. What does the source material say makes for a successful review?
Several things really stand out. First, clear objectives. Why are we doing this review? And measurable exit criteria. How do we know when we're successfully done?
Knowing the goal and the finish line.
Exactly. And the sources are very clear. Evaluating the people involved is absolutely not an objective. It's about the work product, not the person.
That's a critical distinction for keeping it constructive. What else?
Choosing the right review type for the situation, like we just discussed, that's fundamental.
Right.
Also, reviewing manageable chunks. Don't try to review a 500-page document or thousands of lines of code in one go. Break it down.
Keeps reviewers focused.
And makes it less overwhelming, yeah. Providing feedback to stakeholders and authors is also key. Closing the loop.
And giving people enough time to actually prepare beforehand.
Crucial. Rushed preparation leads to ineffective reviews. People need time for that individual review phase.
Makes sense.
Getting visible support from management. If management doesn't value it, provide time for it, it won't happen effectively.
It needs to be seen as important work, not an interruption.
Exactly. And making reviews part of the culture. A positive thing. Focus on collaboration, learning, improving the process, not blaming individuals.
That cultural aspect sounds huge.
It is. Plus, providing adequate training. People need to understand their roles, the process, maybe specific review techniques.
And finally,
Effective facilitation, especially for those review meetings. Keeping things focused, constructive, moving forward. A good moderator is worth their weight in gold.
so wrapping this up then, this deep dive really highlights that finding problems isn't just about running software, is it?
Not at all. Static testing, especially through these structured reviews, is just this incredibly powerful early way to find defects.
And improve quality across all sorts of things, requirements, designs, code.
Long before you'd ever catch those issues with dynamic testing.
It's not about replacing dynamic testing, though.
No. It's a vital complement. They find different kinds of problems. Using both gives you a much more complete, robust approach to quality assurance.
And ultimately saves time and money by catching those really costly problems early on.
That's the bottom line.
Absolutely. And, while we've focused heavily on software development, because that's where the source material comes from, these core ideas, static testing, reviews, they feel incredibly versatile.
How do you mean?
Well, the principle of getting different eyes on a plan before you execute it, having a structured way to find potential issues in any important document before you go live, having a colleague proofread something.
Yeah, that applies way beyond code.
Totally. So a final thought for you listening. Think about your own work or even personal projects. What proposal, plan, document, maybe even a creative piece could benefit from a static test?
A careful review by the right people before you commit or release it is a principle that could prevent headaches almost anywhere, couldn't it?